Hi physics friends, this is Mr. Zarzak. In this video I am going to work through the problems in the speed practice problems. Okay, so question 1 says define the term speed. Your instructor may have asked you to put this in your own words. I certainly asked my students to do so. So I will give you a definition, but you should try to put this in your own words based upon your prior knowledge, what you find on the internet or class notes. Okay, so the term speed, one way we could define this is the rate at which distance changes with time. Okay, and so literally from that definition, the equation pops out. So if I want to calculate speed, the variable for speed is s, and we just look at speed is equal to distance divided by time. See, so whenever we divide something by time, that indicates a rate. So think like miles per hour or meters per second. Those are units of distance divided by units of time, just like we saw in the bus lab. Number 3, rearrange the equation for speed to solve for distance. Okay, so just so you can see the steps, I'm going to start by rewriting that equation that I just wrote above. Speed is distance divided by time. And it says to rearrange it to solve for distance. So we want to isolate the d variable. Okay, so to do that, right now we are dividing distance by time. So to get that time out of the denominator, I'm going to take and multiply that by the time. But if I do it to one side of the equation, I need to do it to the other to maintain the equality. When I do that, okay, you'll see that the time variable factors out, and I'm left with this time times speed is equal to distance. Okay, so I'm just going to take and rewrite that a little nicer. Since this says solve for distance, d is equal to s times t, or speed times time is equal to distance. All right. Number 4, it says rearrange the equation for speed to solve for time. Okay, now I can use the distance is equal to speed times time, but just so you can see it, I'm just going to do all the algebra starting from speed is equal to distance divided by time, just so you can see that this time variable here, it's in the denominator. So factoring out the distance variable just by itself is not going to be enough. It's just going to leave us with 1 over time. So I don't really want to deal with that. So I'm going to do the exact same thing I did in the previous question, where I'm going to multiply both sides by time. Okay, and that's going to allow me to factor out that time variable from the right side of the equation. Okay, so it'd be like, that's like my first step. I'm going to go ahead and rewrite this time times speed is equal to distance. I'm not going to rearrange it like I did in question 3 just yet because I'm still working here. All right, so then the next step is going to be to take and factor out the speed from the left side of the equation. So I'm going to divide out speed on this side and on this side. And when I do that, you'll see that the speed variable cancels out, and I'm left with time on one side and distance over speed on the other. So then I'll just take and write that a little cleaner. Time is equal to distance divided by speed. Okay, and so what I have here is 3 different versions of the same formula. Okay, it's just the same formula rearranged for the 3 variables. So speed is distance over time, distance is equal to speed times time, or time is equal to distance divided by speed. Okay, so now I can use any one of these I want depending upon what information I'm given and what I'm being asked to solve for. So number 5, a car travels 25 kilometers in 2 hours. What is the speed of the car in kilometers per hour? Okay, so if you look here, I'm given kilometers, which is the unit of distance, hours, which is unit of time, and I'm asked for what is the speed. Okay, so since I'm solving for the speed, that's my unknown. All right, I'm just going to scroll back up and say, you know what, that first version of the equation, speed is distance over time, is what I'm going to use here. So speed is distance over time. Step 1, equation. All right, step 2, I'm going to sub in my numbers. So speed is 25 kilometers divided by time of 2.0 hours. That's step 2. And then finally, step 3, I do my math. 2 goes into 25, 12.5 times. And my units of kilometers in the numerator and hours in the denominator stay just as they are. Kilometers per hour is a valid unit of speed. And so there we go. I've computed the speed. All right, moving on to number 6. How long does it take in seconds for a runner to run a distance of 14 meters with a speed of 3.5 meters per second? So same kind of approach. All right, so it says how long does it take in seconds? So time is going to be on my unknown for a runner to run a distance of 14 meters. So I've got a distance of 14 meters and a speed of 3.5 meters per second. All right, so time here is my unknown when given distance and speed. So if I just scroll back up here, I can see time is equal to distance divided by speed. All right, so I'm going to start by writing that. Time is equal to distance divided by speed. All right, that's my first step. Then I'm going to sub in the information that I have. All right, so my distance is 14 meters. Okay, and I'm going to take and divide that by my speed of 3.5 meters per second. Okay, if I take that and plug that into my calculator, that's going to get me my numerical value. So let me get my calculator out because I didn't have it handy. So 14 divided by 3.5. Okay, so look at that, I get 4. All right, and I'm taking meters divided by seconds, which is a little bit funky, but I have solved for a time, and I know I've got the right equation, and the units really do work out. This is going to be 4 seconds. See, if I look here, my time variables here is in seconds. My time unit, I should say, is in seconds, so that's what it's going to work out at the end, okay? All right, number 7, how far has a plane traveled after 12 hours flying at 520 miles an hour? Okay, so I'm looking for how far. So I'm looking for a distance when I'm given a time of 12 hours and a speed of 520 miles an hour. All right, so given that I'm looking for distance, I can scroll back up here and say, oh, look at this. Distance is equal to speed times time. All right, oops, pardon me. All right, so here we go. Distance is equal to speed times time. So that's step 1. Step 2, plug in my speed, and that's 520 miles an hour times my time of 12 hours. Okay, notice when I do this, I have units of hours in the denominator here, but it's actually in the numerator up here, so that's why those hour units factor out. Okay, so I just take my 520 and I multiply that by 12, and that's going to give me my answer. So I probably should have spaced this a little bit nicer, but that's okay. So I get 6240 and my units of miles. Okay. All right, and last but not least, number 8 says the car travels 25 meters in 2 seconds. What is the speed of the car in kilometers per hour? Okay, if I scroll back up here a little bit, I feel like I've solved this one. A car travels 25 kilometers in 2 hours versus a car travels 25 meters in 2 seconds. Okay, so pretty tricky here. First things first, all right, speed is equal to distance over time. All right, so I'm going to take that speed as 25 meters divided by 2 seconds. Okay, so it's going to get me 12.5, but the units here are meters per second. All right, and they want us to take that and convert it to kilometers per hour. All right, so to do my conversion, I've got to do 2 things. I have to convert meters into kilometers, and I have to convert seconds into hours. Okay, so some equalities that we got when we did the bus lab. All right, the 1,000 meters is the same as 1 kilometer, and 3,600 seconds is equal to 1 hour. Okay, because of these equalities, all right, I can set these up as a series of proportions. Okay, and the method that I'm going to use to do this is what's called factor unit label. All right, so I'm going to show this to you down here. I'm going to start with my speed is equal to 12.5 meters per second. If I look at the units, all right, in my units, meters is in the numerator and seconds is in the denominator. And that's important with how I'm going to set up my ratios. All right, so first let's focus on the distance part, the meters part. Okay, I'm going to wind up multiplying this by a fraction where I'm going to try to eliminate meters in the numerator and replace it with kilometers. See, because when I'm done here, I want my answer in kilometers per hour, so kilometers over hours. All right, and so in order to do this, I'm going to write 1 kilometer up here in the numerator, and I'm going to write 1,000 meters here in the denominator. And when I do this, you'll see that the units of meters factor out, And if I did this mathematical operation, I'd just be left with units of kilometers in the numerator, which is what I want. Okay, so that's like halfway there. The next thing I'm going to do is take care of that time. I'm going to convert that time from seconds to hours. So I'm again going to multiply by a fraction. Now, over here, seconds is in the denominator, so to eliminate that or factor it out, I'm going to put my seconds up in the numerator. All right, and when I'm done, I want kilometers per hour. Per means to divide by, so I'm going to put hours down in the denominator. For 1 hour, I need 3,600 seconds. So see, I'm just going to match. All right. Now, mathematically, this is like saying I'm going to take 12.5, multiply by 1, divide by 1,000, multiply by 3,600, and then divide by 1. Now, that seems way more complicated, okay, than I would ever plug into my calculator. Okay, get used to seeing this with fractions. I'm going to take 12.5, divide it by 1,000, and multiply by 3,600. And that's my calculator work. Okay, so if I go and I just plug that into my calculator, all right, so I got 12.5 times 1,000 divided by 3,600. If I do it correctly, the numerical value I'm going to get is 45. And notice that I've already factored out meters, and I've got a seconds in the denominator, seconds in the numerator. So what am I really left with here? I've got kilometers in the numerator, hours in the denominator, which means I have successfully converted to kilometers per hour. And there we go. All right, all finished. Hope that was helpful to you. If not, talk to your physics teacher because they want to help. All right, see you next time.